So let's see some example. Okay? So I'm going to ask you now tough questions. Now, consider this example of what I did before, in which, this is my image, and here I have a square. Okay? Imagine this is white, and this is black. So I have a very well contrasted image, in which this is black. It's a black square on a white background. And now, what I'm going to do is, I'm going to apply the algorithm that I just told you. For every pixel, I'm going to compute the derivatives. I'm going to build the M matrix. In this case, this is pixel ij. The M matrix of this is going to have some values here, and then I'm going to look at the eigenanalysis. What I tell you is that once I get the R image, if I ask for the top 4 values in the R image, in the coordinates image, I'm not going to get this, 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 and this. I'm going to get something else. Why is that? Why this is not working? What do you think? So you can talk to your neighbor for 30 seconds, trying to find out what is happening here. Why? If I apply the algorithm I just told you, that it's a coordinate detector, and I just take the R image and scan for the top value, and I mark the top value, and then I scan and I look for the second top one, third top one, and fourth top one, I'm not going to get the 4 corners of this square. It has nothing to do. Now I only draw the black square because I want to zoom in. Okay? This is the black square. Now, if I ask you, could you point out where is the corner? Some people would say, this is the corner. And this is the top corner in the coordinates image. This is the first one I'm going to get. When I look for the second one, and I want to find one of the other 3, what is going to happen is that the top value is going to be this one. This is my second top corner. The third corner is going to be here, this one. And the fourth top corner might be this one here. So what is happening is that if you have a value like this one, that is the top one, the neighboring values, like especially these 4 that I mark here, those are going to be very high too. So if you ask for the top 4, probably you may end up just with these 4 here, or with 3 of these and 1 of these. This is not what you want. This is not what you expected, is it? How do we go around this? We use something that is called non-maximal suppression. I'm not sure if this is double P. I need a word corrector now. Is it double P? Suppression. 1P. Okay, so lucky me. Okay, this is called non-maximal suppression. This means that any point, like this one here, I'm going to use a different color now. Not that you see very well the colors in the screen, but if I use this point here, and this is the maximum, any pixel that it's not locally, so if I look at the neighbors of this pixel, I look at a 3x3 window, and I say, oh, this pixel is smaller than this one, then I'm not going to take this as a corner. So I'm going to remove any point that it's locally non-maximal. And this is called the non-maximal suppression. So any point that doesn't have a coordinates value bigger than all its neighbors, it's never going to be considered as a corner. Why? Because then this is going to just jeopardize my corner detection. Yeah. It's 2 P's, okay, good. All right. So, unlucky you and me. That's right. Then what is going to happen if we use this non-maximal suppression? Then it's going to work out. Because what is going to happen is that we're just going to, well, I'm not sure how to delete this selectively, but what is going to happen is that I'm going to say, okay, for this, for this this top value here is going to be my first corner, and then I'm not going to take into account any of these values. The second top one is going to be this one here, and I'm not going to take any of the neighboring values. And the third one is going to be maybe this one here, and I'm not going to take any of the neighboring values. And the fourth one might be this one here, and I don't take into account any of the neighboring values. Okay? And then if I apply this non-maximal suppression, I'm able to detect the four corners of the image. All right? Why do I get the four corners, like the top four on the same point? You don't need two. You might find two and then two more in some other corner. Or maybe you find three and another one. But the thing is that if you take the maximum, the neighbors of this maximum are very likely to be very big too. I'm going to show you this in this example. Consider these two images here, okay? These are the two images of a giraffe. You see there's a bright spot here. You know, this is brighter, this is darker. This is the real situation. So you take a picture, you move your camera, you take another picture. Lighting is different, camera gain is different, exposure time might be different, and so on. And you have a bright spot here because of the lighting of this indoor scene, for instance. This is what you get as R. Look at the red patches. Do you see any red point that is isolated? You don't. Why? Because when you have a high value of cornerness, the neighbors of this point also are very big. You see, so here, if I look at this area here, I see several pixels here have high cornerness value, right? Then if I just threshold this R, what I get is a patch like this. And this is not what I want. I want to detect points, which is the pixel at which I get the maximum value, okay? Then if I do just the points that are local maximum in this, so this is one way to go. I can threshold this image, and I create a mask, and now for every blob here, I take the peak, for instance. Now, depending on what threshold I set, my blobs might be different, but I could then select the maximum locally for every blob. Another way to go is just you scan the image, and you look for the maximum. Once you detect the maximum, you ignore and you mask out all the neighbors around in a big enough neighborhood, depending on how close you want corners to appear. For instance, some people say, you know, I don't accept that a corner is just 2 pixels away from another corner. These are not two corners. This is coming from the same feature, provided the resolution of my image, provided, you know, all the conditions of which I'm taking images. You will set these thresholds also in the lab session. You will have to decide, okay, you know, how close do I want the two corners to appear? Okay, and this is just an example of what you get. These are the corners that were detected in these two images. Look at these corners here. So do you think these are salient points? Are these corners? They're not. These are lighting artifacts. So this is something that is going to happen to me once I get this image like that.